It is important to understand the relationship between the velocity used in the aerodynamic force equations and dynamic pressure. The velocity being the speed of the aircraft relative to the air through which it is moving, the true airspeed, or TAS. At a given angle of attack, a constant dynamic pressure must be maintained to maintain a constant lift force. When an aircraft is flying at an altitude where the air density is other than sea level density, the TAS must vary in proportion to the air density change. With increasing altitude and decreasing density, the TAS will increase if the indicated airspeed, IAS, and thus dynamic pressure are maintained. Air density at the time of takeoff and landing can significantly affect aircraft. For example, if air density is low, a longer takeoff run will be needed. Air density is a product of pressure, temperature, and humidity. Humidity actually reduces density because the density of water vapour is about 5/8 of that of dry air. Low pressures and high temperatures also reduce density. On an airfield at sea level with standard pressure, if 1013, 1013 millibars or hectopascals is set on the altimeter, it will read 0. This is known as pressure altitude, which is what will be indicated whenever 1013 is set, regardless of ambient pressure, and is used for performance calculations. You can think of it as altitude relative to standard pressure. If in this case, with a pressure altitude of 0, the temperature is above the ISA sea level standard of +15 degrees, the density of the air will be less, and perhaps a lot less, with no direct indication to the pilot. If the temperature is +25, it would be 10 degrees above standard, or what is referred to as ISA +10. The density would be that which would exist at a higher altitude, and would be referred to as a high-density altitude. In practical terms, this means that the aircraft would need a higher TAS for a given dynamic pressure, and thence a longer takeoff run to achieve the necessary rotate IAS. To remember what a high-density altitude means, just think of it as high-density altitude.